All right, guys, we got this torn down just about as far as we're gonna go. Just wanna take a second and discuss what we're doing here and why we're not doing a full-blown restoration. I really want to restore this machine full bore, traditional fashion, where we go through the whole machine, tear it down, repaint it, make it look perfect, repair it, get it back to factory condition, and then upgrade it into better condition with power feeds, new oiling system. I have a new DRO, a spacer for the head, basically the full 9 yards, ball screws. That's what I really want to do with this machine. However, this is a machine that I use very frequently, and it's a moneymaker at the end of the day. And if I do that with this machine, it's going to be down for 6 months, best case scenario. And I just really can't afford to have this machine down for that long until I get my other mill up and running, so I have another mill I can use while I'm working on this. For that reason, what I'm trying to do here is tear the machine down, get the oiling system working, and just make sure everything is clean and tight. That way I can use the machine to its full capability, which I have not been able to the entire time I've owned it, which has just been about 1.5 years. And then I can operate it in that condition. It'll be a lot easier to use, get a lot better results, and then when the time comes and I have another mill around, I can go ahead and tear this down fully and do a full-blown restoration. So I just want to tell everyone that, just so everyone has some context of what we're doing here. So basically we're going to leave the knee on the machine. We just took the table off, took the saddle off, that way we can inspect the wear. I can redo the oiling system, make sure I can see it working on the system. That way when I know that I put everything back together, I know this machine is going to be tight, it's going to work properly, and it's going to have proper lubrication, which will prolong the life of the machine. So that's why we're kind of doing all this. So where are we at with the saddle and the table? So the table looks pretty good wear-wise. It really doesn't have a lot of wear on the actual table itself. It looks very clean, very straight, not very many nicks. The saddle, and I'll give you some close-ups, looks pretty dang decent. It's not perfect, but considering the age, it looks really good. Probably the most worn part of the whole thing is over at the knee, and that's about what I expected. I'm actually really happy with the level of wear on the rest of the machine, and I want to save that condition as long as I can. So we're going to move around over here, and I just want to talk about some of the stuff we're going to be using for this refresh. I'm not even going to call it a rebuild. So I bought a brand new Bridgeport pump. All this stuff I purchased from H&W Machine Repair. Not a sponsor, but they're great at what they do. They're kind of the experts when it comes to this Bridgeport restoration business. And they sell all the fittings, everything you need, pretty much any part that you would need to restore or fix a Bridgeport. Those guys have it, and they're very, very helpful. So we bought a brand new pump from those guys. I will save the old one just in case I want to rebuild it one day. We got new way wipers, and we have new hoses so we can rerun all the oiling system. We have a whole Bridgeport system rebuild kit. This is pretty much going to come with everything except for a new manifold, I believe. It might have a new manifold in there. It's hard to tell. It's been a while since I bought this, but I'm going to replace all of the meters, all the lines, pretty much everything on the oiling system will be new. And then there is a new flex hose as well, which goes from the actual pump over here to the knee and saddle. We also got a way cover kit from those guys as well. And this guy is a no drill way cover install. We'll see how we like that. Hopefully this turns out pretty good, but the idea is just to keep the chips off the mating surfaces and just keep the machine clean. And then as we talked about earlier, I already opened these, we have new cross feed nuts as well. And then I have a couple other accessories. You know, we have like a clamp for the quill, a bunch of Edge Technology stuff. I actually purchased about 80% of the stuff for this rebuild like 1.5 years, and it's been sitting on the shelf. I have 2 servo power feed units over there, a Mitutoyo quill measuring system, and a brand new Kurt 6-inch vise, and a couple other things. Oh, I have a 6-inch spacer for the mill, and a brand new Newall digital readout system. So when I get it back together, I'm going to think about which of those parts I want to put on, if any, just so I can have better usability. Right now I do have a digital readout on there, but it's an import one, and it does work fine, but it doesn't have anything on the Z-axis, and that would be really nice. So it's very probable that I'll put the power feeds on there and put the new DRO on there. Probably leave the spacer off unless I need it for a job, and then I'll install it and leave it on. And I might slap the new Kurt vise on there as well. That's pretty much where we are. I'm gonna get the saddle torn down and just start replacing a lot of the oiling, and then get everything cleaned up, and then we can start reassembling. I went ahead and installed a whole new Bijur manifold, meters, and new actual tubing. We're gonna go back over to the mill and go ahead and work on the oiling system on the side. And then once we're done with that, we'll go ahead and reinstall this and just test to make sure everything is working. We're gonna come in here and remove these way wiper covers. Even though we're not removing the knee, the reason I'm doing this is so I can inspect the way wipers, which are shot, and I figured they would be, and then take the gib out and inspect that. I would have thought that would want to fall off, but I'm not gonna mess with it. It's worn. Doesn't look super bad. We still have flaking 80% of the way. Well, here's a better look at the gib. You can see we do have flaking the whole way. Right down here at this other end down here, we're losing a little bit. It's pretty strong all the way across. I'm pretty happy with that. That goes in line with what I suspected as far as the wear on the knee. I'm gonna reinstall it. We're not gonna inspect it or anything. I'm just doing a visual. All right, we're gonna come in here and remove all this old oiling system. And these nuts are 3/8. So we'll just remove these guys. And the T-fitting. I'm sure all this is original. It was not a retrofit. Whoever ordered this mill ordered it kind of decked out because it had the chrome ways, had the oiling system. So this has been on here at least 60 years. It would probably be fine if we just rebuilt it, but being that old, I'm gonna opt for a replacement. All right, and then for the pump, just 2 flat heads, and then it comes right off. And I'm gonna bet you that the new one lines right up. All right, we're ready to install the new pump. Let's see if the holes line up. I have faith that they will. It's just amazing to me that you can have a brand new part be an exact fit on something that's 60 plus years old. It's kind of nice to see that, actually. All right, we'll go ahead and get our T set up here. I'm just going to loosely install this because we're going to install our little line from the bottom up here, and I want to be able to remove this. There we go. All right, we have a little bit of cabling left, or tubing. We're going to feed this through. If I do run short, I'd rather use a short piece there than try to put 2 pieces together here. I don't think we're going to run short though. All right, we're going to start by removing the plug here. And then we're going to go ahead and take our hose and install our cap, ferrules. All right, we're going to come over here and install our hose. This is 3/8, just like all the other ones. All right, we're gonna address this loose knob down here. You would think it's just as simple as tightening it, but I can tell that it's definitely bent. So I'm gonna take this whole end off. It looks like a tapered pin is holding it on, and we're gonna bring it over to the lathe. I'll make a new handle, slightly longer. We don't want too much leverage on it. We'll go ahead and thread the end of it, throw a hole in the end, that way we can keep it from coming back out again. All right, got that tapered pin. Yeah, didn't intend on taking the whole thing out, but guess that's what they wanted. All right, guys, we're over here at the lathe. We're gonna be making a new handle for the Bridgeport knee. I'm gonna make it a little bit longer than this, maybe an inch longer, not too much. We have a nice piece of stainless here. Not really necessary, but why not? I'm gonna get this faced off. We'll throw a center in it so we can support the end. And then we'll do a tapered handle with a little round end, just to be fancy for no real reason. Face it off. We'll throw a center in it. The first thing we're going to do is turn this in back for the threaded section on the end and end in a shoulder. It is a 5/16 18 thread. So we're going to turn the outer diameter of this to 5/16, and then we will do a shoulder, and then we'll taper from here on over. Just come in and touch off. None of these dimensions are critical. That'll work. I'm going to switch tools just because we're getting a little close to the center here. We're going to use this guy. And we're going to take a measurement. All right, 780, 709. So I'm going to set my DRO, 0.709. And we're trying to get down to 5/16. 3125 would be what we're going for. I'm gonna touch off. Let's just take 100,000, see how it does it. Not quite breaking the chip. Let's just do another like 50. Let's up the feed rate. There we go. Not ideal, but it's working. There we go, let's take something similar to that. Not quite as deep. Says we're at 450 thousandths. Let's bring it down to 380 and then we'll check it. We'll need to go in there and clean up that shoulder. You probably hear a little bit of noise. That's the length of this bar flopping around on the back. I haven't built a roller stand for the back of the lathe yet. All right, we're at 380. Yeah, we're pretty much on the money. All right, it doesn't really matter too much here. We're just gonna bring it down to 3125. This is not that critical. I'm just gonna go right down to 3126. Within 1,000th, I think it'll be fine. And then we'll go and clean up that shoulder. All right, we'll check it. That'll be fine. All right, I'm gonna go in there and clean up that shoulder. right, that'll be perfect. All right, I'm gonna move it back in the chuck so I can chamfer the end. Just a mild chamfer. That should be fine. All right, we're gonna have a little fun with this one. We're gonna come in with our tailstock die holder and thread this real quick. Let's reverse out. Not too bad. Let's just check it with the part here. Obviously it's not gonna seat, and these threads were pretty loose before, but yeah, it's a fit. All right, great. All right, there's a little shoulder in here. I'm gonna match that just so it seats flush. Maybe 1/8 tall, maybe, we'll just see. So I'm gonna get a measurement on that and we'll do a little shoulder here. We're gonna do 470 thousandths. It's measuring a little bit more than that, but we'll just leave a little room for clearance. Come in, touch off. That's about all we need. $755 it looks like. All right, and we're looking for 470. Now, we got a lot of crud in here, so I don't think that's gonna just go on perfectly, but I just kind of want to get an eyeball on it. Oh yeah, that's gonna look real nice. Okay, loosen the chuck. All right, I'm just gonna roughly check here so we can get a length. I wanna do about 4.5, but I'm gonna do about 4.75 so we can face the ends, get rid of the centers if we need to. All right, I just want to measure this guy out. I'm looking to do about 4 3/4. I'm just going to go ahead and make a mark with the parting tool. All right, that'll be my end. All right, ready to start cutting this taper. It's going to be a little iffy. We don't have the best tailstock support here, and the spindle on this machine needs to be adjusted, so I'm not trying to win the surface finish award. We're just trying to get it done. The taper that I've chosen is just a random number. The degrees, what I mean. None of this really matters. I just want it to look a certain way. Using my drill power feed here. Turn that down, a little more aggressive than I would like. All right, I don't need to go that fast. Though I am roughing it, so it might be fine. Not gonna lie, that's kind of a cool effect. I don't know that I'm gonna run with that, but it does look kind of cool. We need to make an adjustment here. Our angle is visually pleasing, but I don't think I'm gonna make it to here at the shoulder. So I'm gonna decrease the steepness of this angle so we can try to get it closely in one shot. This is really just guesswork. This is where you get to have fun. No diagrams, no measurements. Just trying to make something cool. A little heavy on the cut, but we're gonna do it anyway. It actually cuts better on the heavier cut anyway. I think we're gonna get the angle we're looking for here. I'm gonna lock my carriage down. It did just move on me during that cut. Let's go forward again. Yeah, it's a little heavy. I'm just gonna run with it. Not gonna lie, that turned out a lot thinner than I would have liked it. That last cut did me. Let's see how loose of a fit it is gonna be on this guy. It might end up being fine, but it looks like it's gonna be fine. It might end up being perfect. I just would like to have crept up on it a little bit slower, but that's why none of this really makes a difference. All right. I'm gonna come in here and take a finish cut. That's looking really nice, really nice. I'm just going slow on the drill. I don't know how much I'm taking off, but it's looking really good. I'm kind of running out of travel too, so I'm not gonna be able to make it as long as I want, but that'll be fine. All right, that finish wasn't bad. I have a low spot here, probably because the tool flexed a ton. I think what I'm gonna end up doing is just going straight for that last little part. Let's just straighten that last part out. I'm not gonna go that full length, so it doesn't matter. I'm gonna come back until I land on my taper. All right, I'm gonna take a finish cut backwards. Oh, that was a complete failure. All right, guys, let me bring you up to speed. I decided that I didn't like the taper angle of this handle for the knee lock, so I'm gonna make another one, but I was gonna make a handle for the X-lock for this guy, and this is actually perfect because I can cut it a little bit shorter and the taper looks decent, and I'm just gonna run with it. So we'll use this guy for the X-lock, and I'll make another one for the knee lock. Stuff like that just happens, especially when you're not doing any measurements and you're just winging it. So this will end up working out, just not exactly what we intended it for. I'm gonna go ahead and make some clearance for our next tool by coming in here with a parting blade. I would like to round over this, and I've got a tool that I want to use, but it doesn't fit without some clearance. So we're just trying to get in here and give it some room. I don't want to weaken this area too much. It is a compromise, but I want to be able to get the room I need. And that should be enough room right there. All right, we're gonna try a little trick here. I've got a radius end mill that we're gonna use, and it's designed to be used in the opposite direction. So I'm gonna run the lathe in reverse. I've set the center height to the bottom, and we'll see if this works out for us. All right, it's working, but this radius is too big. I'm gonna switch to a smaller cutter. Seems to be working. And we're bottoming out. Yeah, that's working. I'm gonna move it over a little bit. That's working well. I need to make a little more clearance. Feel like it's gonna get dicey, but the problem is I can't chuck up over here because it's a taper. So we're kind of doing what we can. There we go. That's already probably a little risky. Well, let's just see. Stainless is pretty strong, so I'm kind of hoping on a wish here. Looks like I might hit on that other side, but it might start cutting. No, it's just gonna drag. Gonna make a little more clearance. All right, let's give this another shot. There we go. That worked out well. I'm gonna polish it up and then we'll part it off. All right guys, the handle is done. I'm really happy with how it turned out. Originally I wanted a little bit more taper and a little bit more length, but in the end the shorter handle actually works out a little bit better, and now that I see it in place, I really don't want it much longer than this because I don't want it hanging down. So I'm really happy with how it turns out. The lock works properly. In the down position, it's completely unlocked, and I have plenty of travel to really get the knee down tight. Works great, looks great, nice and tight. I'm very happy with this. Another issue I want to address on this mill here is this lock for the Y travel. This threads in, and it stays in, but you guys can probably tell these threads are completely toasted. And I want to make a handle that's just slightly longer, nothing crazy, about a ½ inch longer, and I want to have a way to pin this. So I'll probably do something from here in the end, or maybe a cross pin. It needs to be removable so we can thread this in and then install the handle. But what I don't want is, the problem with this design is it relies surely on the threads, and once the threads get worn and loose, they go bad and it gets loose. So we're gonna reuse this part here. We may re-tap the threads in there depending on how bad they are. I might drill it out a little bit bigger, and then we'll make a new handle over here on the lathe. All right, we've got a 1-inch piece of stainless chucked up in the Jacobs rubber flex collet. We're gonna go ahead and center drill the end, that way we can do an end support, and then we're gonna make this handle in this orientation right here. So we'll go ahead and round the end with a nice heavy round over, and then we'll come in here and we'll do a taper, and then we'll thread this end. The last handle I did in this orientation, and it was nice because I could do the threads with the tap, but we're gonna try something else and do it this way. This will make doing the threads a little bit more difficult, but make doing the round and maybe the taper a little bit easier. So we'll see how it goes. I might as well come in here and just face the end real quick. Nothing too crazy, just enough so we can get the center in there. A little deeper. All right, that should be fine. All right, we're gonna come in here and put our nice heavy round on the end. And I see that our center gel is probably gonna be in the way for this. So we're gonna remove it. I'm actually gonna bring this closer to the chuck for rigidity's sake. All right, let's get this guy rounded. We're gonna go a little bit slower. Do a little bit of cutting fluid. Seems to be cutting really nice. Turned out really, really nice. So here's the situation. I went ahead and re-tapped this hole for 3/8. It was 5/16. And I'm gonna leave this shoulder here to add additional length, about a 1/2 inch roughly. And that shoulder is gonna perfectly nest inside of that counter bore. I'm gonna turn this down and we're gonna do a 3/8 16 thread. So I need to get the outer diameter to this down to 375. This is gonna be 480, which it is already. And that's gonna nest perfectly inside of here. This is like 5/0. I'm using the parting tool here so I can get in there and get a square shoulder. And then we'll take a measurement. It'll be rough. That's 430. .413. This is not the best practice in terms of turning, but It'll work. All right, we're a little under, but it'll work. The last part of this operation is threading right underneath this shoulder. Now we could have left this in the chuck and single point threaded up to the chuck, but frankly, it's a little bit unnecessary in my opinion. So what we did is we went ahead and created a bushing that we can slide over. And what that will allow us to do is slide into the chuck, and we put a slit on that bushing so that we can actually clamp down, and that will hold our part firmly so we can do our last threading operation with a die. All right, we're gonna go ahead and thread this with a die. And then reverse. There we go. Nice and easy. All right, we're gonna just get rid of that little nub on the end and we should be set. And then I'm gonna face this down a little bit. And then I'm gonna re-chamfer just a little bit. That's it, nothing crazy. And that fits perfect. The shoulder right here is a little bit big, so we're gonna turn that down. But the thread seems to be fine. All right guys, we finished the handle. I'm really happy with how it turned out. We went ahead and put a set screw in the end, that way I could keep this thread tight. It's not that much larger than the old one, maybe a ½ inch longer, maybe. So we shouldn't have a problem with clearance, but it definitely feels nice in your hand, nice and smooth, has a good grip to it, looks really nice. This is probably mild steel, this is stainless. Yeah. I'm really happy with it. Turned out really nice.